Hello everyone, what's up? Harshit Tyagi here, and this video is part of the new series called Data Science Monthly, where I will be reacting, demonstrating, or simply sharing cool, new, and sometimes old projects in the world of data science and AI. And this is kind of like a monthly news in the data science space. But if you guys enjoy it, do let me know in the comments and we can make it a weekly thing. So this is just one of the ways I can be more consistent with my output here on YouTube. And so how should we do this? Why don't you guys just watch this and I'll see you at the end of the video. So the first update of the month is the stable release of Python 3.9.0. Now the release was announced on October 5, 2020 with the Python community announcing it on Twitter and various other platforms through some blog posts as well as tweets by the creator himself, Guido van Rossum, and a few others from the core development team. The major new features of the 3.9 series are basically 573, 584, all of these PEP codes are listed over here. The major ones that I feel are type hinting, generics in standard collection. The other one is support for IANA time zone database in the standard library through the zone info module. Then we have relaxing grammar restrictions, and there's new peg parser for CPython, and there are a bunch of other things. Now I have written a blog post covering all the major updates in Python 3.9 along with some cool highlights as well. So this is basically like a side-by-side comparison with the Python 3.8. So I'm covering type hinting generics and flexible function and variable annotations. So annotations were already available, but now we can add data type to those annotations. Union operators and dictionaries, there are two new operators that have been introduced for dictionary merging process. And then we have zone info module that's been introduced. So working with different time zones is no more hassle. Then string methods to remove prefixes and suffixes. So two new functions, remove prefix and remove suffix. They help you strip off all the prefix and suffix in your strings. Then other cool releases in the other release highlights section. So this is going to be a side-by-side comparison. As you can see, Python 3.8 and Python 3.9, how you did annotations earlier in Python 3.8. There are no data types here. Now you can use the annotated module and add data types to your functions in your annotations. I have added screenshots, how it works, how you can work or use different attributes to get all this information. Then merging and updating dictionaries. So this was an ugly looking syntax for merging two dictionaries in earlier versions, but now 3.9 has this two updates, union and update operators. So the union operator basically merges two dictionaries, but it preserves the original dictionaries, and the update operator is for in-place merging of two dictionaries. Again, I have added this code snippets along with their screenshots. Now the zone info module was introduced, so this has included the entire internet assigned numbers authority IANA time zone database that you can access and work with different time zones all over the world. Then we have remove suffix and remove prefix, two new functions. Earlier we had lstrip and rstrip methods, but there we've been stripping off characters from like either ends and of the string using these strip methods. But the remove prefix and remove suffix, these two functions can now use a bunch of permutation and combination, and you can strip off your strings using these new methods. So other cool release highlights include CPython, the new parser that has been introduced. So this is all based on peg. We can still use the old parser, which is LL1. Now Guido, who is the creator of Python, he said that based on his research, PEG parsers would be more robust. One thing that you should do is check out if your code runs smoothly with the new parser. Here's the command that you can find in the blog itself. Then multi-phase initialization is now available. Python community has adopted this new release cycle that they would be coming up with every new release, a new version every October. So this was under PEP 602. Then PEP 614 is for relaxed grammar restrictions on decorators. So this was all about Python 3.9. You can check out more details from the blog post. So the next project that we have on the list is CNN Explainer. Now this is a very fascinating and very cool project that I came across while scrolling Twitter. Now CNN Explainer is basically a browser-based visual illustration of a convolutional neural network, and it is fascinating to see how we can just simply write a few lines of code using libraries like Keras or FastAI, and we can create state-of-the-art CNN models to classify objects. But understanding the mechanics of how CNN processes an image to obtain the final output is actually very crucial. Now this is where this project comes in, and it explains, it actually gives you a behind the scenes of how a CNN model actually trains and classifies an object. So this entire project was built on TensorFlow.js, which is an in-browser GPU accelerated deep learning library to load the pre-trained model for visualization. And the entire system is actually written in JavaScript using Svelte as a framework and D3.js for all the visualizations that you're looking at. Now, you only need a web browser to get started with learning a CNN here using this particular blog post and this very cool visualization. So you can actually click on any of the neuron that you see, and it'll actually show you what's actually happening. So I have an input layer, and then we have, you can see this is a convolutional layer, first convolutional layer. You can actually click on these and it'll show you how it is training. So you can see the convolutions and the filter. This is basically the kernel. It's a 3x3 kernel. The input size of the image was actually 64 by 64, and after the convolutions and the kernel ran over this image, we got an output after the computations were done. So it's basically just a dot product, element wise dot product that was performed, and you can see all the values, the kernel weights and the biases that were being added. So very cool project to actually learn and understand how every detail is working. You can press on play and it'll keep on running and show you how the processing is being done. Then you get a list of all the layers. So this particular model, this particular system, CNN Explainer, uses a very simple CNN, which is called Tiny VGG, which comprises just 3 convolutional layers, a couple of max pool layers, as you can see here, and a flatten layer to classify an image into one of the 10 classes, which is basically lifeboat, ladybug, pizza, bell pepper, school bus, so on and so forth. So it's just the tip of the iceberg. You can actually use these tools to understand what's a tensor, neuron, kernel weights and biases. You can actually understand what's happening behind each layer: input layer, convolutional layer, max pool layer. What do they do? How do they reduce the size? What are these hyperparameters that we have? So you can actually run. So they have given some really cool visualizations to understand kernels, padding, kernel size, stride in a CNN. And they have also talked about activation functions like ReLU, softmax that we keep on encountering in our day-to-day deep learning projects. So do go through this entire blog post as well as this entire project on GitHub itself, and see if you can collaborate in some way. Really cool project that I came across, and the credit goes to the team. So CNNX, this was created by Jay Wang, Robert Turco, Omar Sheikh, Haiku Park, Nilaksh Das, Fred Hoffman, and Minsuk Kang, and Paulo Chow. So this was a result of a research collaboration between Georgia Tech and Oregon State. Very cool. Kudos to the guys who delivered this really cool article, which helps you learn the mechanics of convolutional neural networks. So another really cool project that I came across was called TensorSensor. So there's this guy named Terence Spur. So he has developed this library, which is basically created with the purpose of handling exceptions when building neural networks, when you're working with neural networks and you're working with different matrices or tensors of different dimensions, and you're using libraries like NumPy, TensorFlow, or PyTorch, and you know that you would be working with different dimensions of tensors. So one of the biggest pain points is to get all of these tensors of different dimensions to line up correctly. So usually, when you are using any of those three libraries, NumPy, TensorFlow, or PyTorch, and you encounter an error which is related to the dimension of the matrix, let's say computing matrix multiplication, so the interpreter basically throws an error which is without any details, without any specifics. It's hard to debug. So what you do is you actually go and write print statements. So that basically gives you what the dimension of that matrix was. So I have created this, I was trying out this library. So it's you can install it like simply like any other Python library, pip install TensorSensor. So I've imported this. It's imported as tsensor. So run this. Now I have created some a sample code. I was trying this out. So here's this rows, which is, let's say, called the number of instances. Columns is number of features, and then there's, let's say, 100 neurons. So I've created like weights, biases, and this is my x, the feature set, and the y, the target variable. So weights, let's say I have created using creating some random numbers for the features for each of those neurons. So this would be my weight matrix. This would be my biases. Biases again, one dimensional, and then I have created my x, which is my feature set matrix. So here rows is 1400 and neurons. So you know that this is so when I'll be computing this dot product, it would be difficult. It would basically throw an error. So let's see. So this is the error which is thrown by the interpreter. Now if we had to find out like what where it went wrong, we'll have to type shape, and similarly you will do that for all of these and find out like where it went wrong. So it gave you that this is the line where the error occurred, but you'll have to figure out by looking at the dimension of each of these. So let's change it. Okay, so now you see we have 400 into 100, 100 into 1, and we are trying to multiply w with the x. So you can see there's the dimensions don't match. Basically get this right, you have to do all of this debugging. Now with TensorSensor, you can actually write this code as with tsensor.clarify, and it will give you this exception message, which is very easy to understand and gets you up to speed, like tells you like where it went wrong. So you see it tells you that the W matrix that you have is 400 by 100, whereas the X matrix that you have is 400 by 1k. So the dimensions don't match, and that's why you're getting these errors. Now there are a bunch of other functions that this guy has written. So there's abstract syntax tree that you can develop. There's explain function that you can use. So do check this out, do try this out. Here I have added the link again in the description. So he has provided snippets for all of these different libraries, PyTorch, TensorFlow, and a bunch of other cool things that you can do. in case you want to customize it to your project or as per your need. So next up, we have this news from Nvidia, where they have launched their cloud AI video streaming platform, which will use GANs, generative adversarial neural networks, to boost bandwidth performance. And as you all know, that during these COVID times, we have been facing a lot of bandwidth issue. Everyone wants to get on a video call, be it business, be it personal relation, be it anything. So video calling has become an integral part of almost all the major industries. So what Nvidia has proposed is that they've come up with this solution where they're using GANs in place of the software called video codec, which was typically used to compress and decompress video for transmission over the internet. Now, their work basically enables a video call with 1/10 of the network bandwidth which users typically need to conduct a video call. Now, how this works is that a sender first transmits a reference image of the caller. Now, rather than sending a fat stream of pixel-packed images, now this system sends data of locations of a few key points around the user's eyes, nose, and mouth. There is a GAN, which is Generative Adversarial Neural Network, on the receiver side that uses the initial image and the facial key points to reconstruct subsequent images on a local GPU. And this is again using Nvidia GPU. So as a result, you would be sending much less data, and the bandwidth requirements will definitely become more efficient. So the technique works even when the callers are wearing hat or glasses or mask or headphones, and they're still working on a more serious thing, which is called GAN's reconstructed free view. So here what they're doing is they're using neural networks to align the position of users' faces for a more natural experience, so that the callers would look like as if they are looking into the camera, because most of us have this habit of looking into the video feed. So we're basically looking at the other person, whereas actually should be looking into the camera. So this would give you that free view where you would get a feeling of face-to-face connection. So that's what they're working on. So the Maxine video calling is something that we should be looking out for in the near future in almost all of our video calling platforms and softwares. Now, the last project of this October series is the coolest one. This is called Google Magenta Tone Transfer. Now, this lets you transform everyday sounds like birds chirping, pans clicking, or your voice, you singing, everyday sounds into musical instruments. So this tone transfer is basically transferring one tone, one type of sound into a very melodious musical instrument sound. And this whole project was a collaboration between two teams within Google Research. So this was Magenta team and the AI UX. So there were a few UX engineers who collaborated and designed this whole flow, and it transforms everyday sound into musical instruments. And this whole system is basically built on a technology that the Google Magenta team open sourced earlier this year that was called DDSP, which stands for Differentiable Digital Signal Processing. And they earlier used to have this only Colab notebook, which they used to use in order to showcase what they have been working on, but now they have created this entire platform that you can use and play around with. So here's what I have for you from Tone Transfer.
If you could have stayed.
Now, they do this by training machine learning models to distill what makes an instrument sound like that particular instrument. And it picks up pitch, octaves, loudness, etc., and remolds everyday sounds into musical instruments. Now, to extract pitch from audio, another model developed by Google Research, which was called Spice, that was used. And upcoming releases will enable you to easily train your own DDSP models and deploy them on a phone or an audio plugin or a website. You can actually check out their GitHub repository, you can contribute to it, you can learn how you can use this particular technology and create something cooler. So do check out this very cool project on audio. So I hope you found these projects cool or useful. They can be new business ideas, new project ideas, or maybe you would want to collaborate or contribute to any one of these. So if you enjoyed this video, do give this video a thumbs up, and do let me know in the comments below what else should I add while reacting to these projects or while demonstrating them, or how else can I make it more entertaining and interesting for you. And do subscribe to the channel, help us grow, and share it with your friends. And I'll catch you guys in the next one. Until then, keep learning data science with Harshit.